All right, hello. We are going to get started in chapter 6, starting with lesson 6.1. So let me present my screen and we'll get started. Okay, so in chapter 6, we're going to be talking about perpendicular and angle bisectors, bisector triangles, medians, altitudes of triangles, mid-segments of triangles, and then we're going to be doing some proofs as well. So a lot of information all related to triangles. Oops, sorry about that. All right, so the first vocabulary word, equidistant. This is actually a term we learned early in the school year. A point is equidistant excuse me, from two figures when the point is the same distance from each figure. Okay, so here it says that line or segment CP, okay, this is line CP, is the perpendicular bisector of segment AB. Okay, and we're going to get into what perpendicular and bisect both mean, but simply put, perpendicular means that it intersects to form a right angle, and bisect, as we know from earlier in the school year, means cut in half. Okay, so CP is cutting AB in half. That's why we have a tick mark on PB and a tick mark on PA, and also CP is intersecting AB such that right angles are formed, so it's perpendicular. All right, so the next thing is a theorem related to perpendicular bisectors, and it has to do with the equidistant term above as well. It says perpendicular bisector theorem. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So above we talked about CP being the perpendicular bisector, and you can see it's still the perpendicular bisector in this diagram as well, because CP is cutting AB in half, because we know that by the tick marks, and it's also perpendicular, we know that by the right angle. So any point that I put along this line is going to be equidistant from A and B. So what I mean by that is, since we have a segment connecting C to A and C to B, and since point C is on the perpendicular bisector, I know that CA is congruent to CB. Okay, if I put another point anywhere on this line, so let's say I put a point right here, and I'm just going to call it point M, and I connect M to the endpoint A and M to the endpoint B. Well, because point M is on the perpendicular bisector, this theorem tells me that point M is equidistant from the endpoints. So that means that MB is congruent to MA. All right, so that's what this theorem tells us. All right. The next theorem is the converse of the perpendicular bisector. Okay, so if we have a diagram that looks like this, where we have this point D, and D is the same distance away from A as it is from B, and I know that because of the tick marks, that means that point D must lie on the perpendicular bisector, meaning that CP is the perpendicular bisector. Okay, so it says, in a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So if DA is equal to DB, which we already said it was when we looked at the diagram, and then point B lies on the perpendicular bisector. All right. So based on that information, you're going to have to look at the diagrams and determine what do you know, okay? And then from there, what can you maybe set equal to each other? What can you figure out? All right, so for part A, you're trying to find the length of RS, the distance from R to S, all right? Well, looking at the diagram and thinking about the theorems above, since SQ is the perpendicular bisector of RP, that means that point S has to be equidistant to the two endpoints. So SP is congruent to SR, and that's based on the perpendicular bisector theorem. All right, so SP is equal to SR. So since SP is 6.8, that means that SR is also 6.8. So I know that this segment here is 6.8, which is what I was looking for. In the next diagram, All right, so if you look, think about what they're showing you here. They're showing you that HE is 24 units long and HG is 24 units long. So this is the converse of the perpendicular bisector theorem. Since point H is equidistant to the two endpoints E and G, that means that point H has to be lying on the perpendicular bisector. So HF is perpendicular to EG, which we can see by the right angle symbol, but now we also know that it's bisecting EG. So EF is equal to FG. All right, so EF is equal to FG. So if FG is 9.5, that means that EF is also 9.5. But let's look at what the question's asking us. They're asking for the length of EG, the whole thing. So to find EG, you're just going to take 9.5 and multiply by 2, or 9.5 plus 9.5, which will give you 19. All right. And for the last one here, I can see that BD is perpendicular to AC. I know it's perpendicular because of that right angle box. And BD is also cutting AC in half. It's bisecting. So that means that BD is the perpendicular bisector. Well, according to the perpendicular bisector above, that means that point D is equidistant from C to A. So I know that CD is equal to AD. All right, so CD is equal to AD. So I can set those expressions equal to each other. 3x plus 14 is equal to 5x. And now I can solve for x. So subtract 3x from both sides. So I have 14 is equal to 2x. Divide both sides by 2, and x is equal to 7. But be careful, what's the question asking? They're asking for the length of AD. So since AD is equal to 5x, and now I know that x is equal to 7, I just multiply. Oh, I'm going to be too low. I just multiply to get that AD is 35 units long. All right, so those are the first 3 examples for today. All right. The next problem says, is there enough information in the diagram to conclude that point N lies on the perpendicular bisector of KM? All right, so let's look at the diagram. Get my pen. All right. So here I see that I have point N. What is it asking again? Is point N on the perpendicular bisector? All right, I see that point N is here, okay, and L there. And I see that NL bisects KM, right, because of the tick marks here. All right, so let's first say the converse of the perpendicular bisector theorem. All right, what does that say? If a point is equidistant from, that's if, from a segment, from the endpoint, sorry. Let's start that over. From the endpoints of a segment. Then it lies on the perpendicular bisector. So that's what I'm looking for. All right, because since it doesn't say that this is a right angle right here, right? If that was a right angle, and since I have congruency markings there, I would then be able to say that NL is a perpendicular bisector, right? But we weren't given that right angle symbol. So that's why I'm trying to think about the converse. The converse says that if a point is equidistant from the endpoint, then that point is on the perpendicular bisector, all right? So even though I know that KL is congruent to LM. I don't know. I do not know if NK is equal, put a question mark, to NM. And that's what I would need to know in order to use a converse. If NK was equal to NM, then I could say that point N is on the perpendicular bisector. But since I do not know that, not enough info. Okay, so there's not enough information to use the converse because I don't know if this segment is congruent to that. And there's not enough information to use the perpendicular bisector theorem because I do not know if this is a right angle. Okay, so too much information is missing. I cannot come to the determination if N lies on the perpendicular bisector. All right, so that's that problem. The next theorem is the angle bisector theorem and its converse. Okay, so the angle bisector theorem says this: if a point lies on the bisector of an angle, then it is equidistant from the two sides. Okay, so if you look at the diagram, I can see that AD is the angle bisector of angle ABC. And how do I know that? Based on the arcs. This angle is congruent to that. Therefore, AD is the angle bisector. If AD is the angle bisector, then that means any point on the angle bisector is going to be equidistant to the sides. Okay, and we measure the distance using a perpendicular segment. So there's a perpendicular segment. Here's a perpendicular segment. So that means that this segment is going to be congruent to that one. Okay, or in their drawing, DB is congruent to DC. Okay, because D is on the perpendicular, or excuse me, is on the angle bisector. It must be the same distance to the two sides of the angle. Okay, and the converse of this is true as well. So if you look down here in the diagram, you're given the distance from A to B is the same as the distance from D to C. So since those distances are the same, that means that D is on the angle bisector. So I can come to the conclusion that this angle, angle ABD, is congruent to this angle, angle CAD. Therefore, AD is the angle bisector. Okay, so again, I'll just read the theorem, but it says if a point is in the interior of an angle and it's equidistant from the two sides of the angle, then it lies on the angle bisector. All right, so that's the converse of the theorem. So we're going to be using these two theorems to look at some algebraic problems like we did above. All right, so what do you know by looking at, there we go. What do we know by looking at this diagram? Okay, I can see that the distance from J to G is equal to the distance from J to H. All right, so this is going to be the converse of the angle bisector theorem. So since, sorry, that didn't work. Let me try writing that again. Since JG is equal to JH, that means that J is on the angle bisector. All right, so if J is on the angle bisector, that means that JF bisector, it should be FJ, wrote that wrong, sorry. Looked at the diagram backwards. FJ, excuse me, ray FJ bisects angle GFH. Okay, so in other words, this angle has to be congruent to that angle. So the measure of angle GFJ, that's this angle here, is equal to 42. It's 42 degrees. All right. Now the next example, what do you see here? I see that SQ or QS, I should name it QS, is the angle bisector of angle PQR. And how do I know that? Because it's marked. This angle is congruent to that. Therefore, this is the angle bisector. All right, any point that's on the angle bisector is equidistant to the two sides of the angle. So in other words, this segment SP is equal to this segment SR. So I can say that SR is equal to SP. 6x minus 5 is equal to 5x. Subtract 6x from both sides. So negative 5 is equal to negative 1x. Therefore, x is equal to 5. But you're asked for SR. You're asked for that length, or RS is how they're naming it. Flip the letters around. So SR is equal to 6x minus 5. So we have 30 minus 5, which gives you 25. All right. Let's move on to the next one. Okay, solving a real life problem. A soccer goalie's position relative to the ball and goalpost forms congruent angles. Congruent angles. So I don't know if you can see in the diagram, it's very faint, but they're saying that this angle is congruent to this one. Okay, the soccer goalie's position to the ball and to the goalposts forms congruent angles. So that's what that was saying there. And it's marked. It's just kind of hard to see. Those two angles are equal. It says, will the goalie have to move further to block a shot, to block a shot toward the right goalpost R or the left goalpost L? Okay, so does the goalie have to move further to get there or there? So think about this for a second. Well, is the goalie standing along the angle bisector? If the goalie is standing along the angle bisector, doesn't the theorem tell us, the angle bisector theorem tell us that the goalie is equidistant to the two sides of the triangle? Even though it's not a formal triangle, I can make it one, right? So the goalie is equidistant to both post L and post R because he lies on the angle bisector. So we'll say if the goalie is on the angle bisector, he or she, I guess, she would have to move equidistant to goal post R/L. Okay, so he's going to have to move, or she's going to have to move equidistant to block a shot to L or R, since he or she is standing on the angle bisector. All right, hopefully that makes sense. Okay, and I think, let me double check. This might be the last problem for today. It is. Okay, so it's a multi-step problem here. It's write an equations of perpendicular bisectors. Write an equation for a perpendicular bisector of a segment with endpoints P, -2, -2, 3, and Q, 4, 1. So let's first plot those points. So -3, I might need to make this bigger. Hold on. Just so it's easier for me to graph the points. -2, 3. Here's one of the endpoints. And then 4, 1. All right, so here we have a segment. Good, draw straight. There we go. And our goal is to write an equation of the perpendicular bisector. So we want to come up with the equation of the line that is perpendicular and bisects this segment. Okay, and this is P and this is Q, PQ. All right, so what do we need to know? Well, first we need to know where to draw that line. So think about it. How are you going to figure out where this line is supposed to go through? If it's the perpendicular bisector, it has to go through the midpoint. So the first step is to find the midpoint of PQ. So first you're going to find midpoint of PQ. All right, so we do have our midpoint formula, which is x1 plus x2 divided by 2, and then y1 plus y2 divided by 2. You're finding the average of the x coordinates and the average of the y coordinates to find the midpoint. So it's going to be negative 2, that's x1, plus 4 divided by 2. And then we have 3 plus 1 divided by 2. Okay, that'll be the new coordinate of the midpoint. So when I do the math, negative 2 plus 4, that's 2. 2 divided by 2, that's a 1. And then 3 plus 1, that's a 4, divided by 2 is a 2. So the midpoint should be located at 1, 2, which looks right? If that's the midpoint, then that means that's congruent to that. So that's the first step, is to find the midpoint. Okay, now I know my line is going through this line, but how do I know how to draw it? Should I draw it like here? Should I draw it more like this? Should I draw it over here? Right? How do you know? Well, if it needs to be perpendicular, I first need to find the slope of this line, because my slope is going to be the opposite reciprocal. Okay, so let me erase this step. The second step is to find the slope of PQ. So second, you're going to find slope of PQ. All right, and to find the slope, you can use the slope formula, or you can come over here and just do rise over run. But the slope formula is change in y over change in x. Oops, x2 minus x1. All right, so we're going to set it up as 3 minus 1 over negative 2 minus 4. So 3 minus 1 is a 2. Negative 2 minus 4 is a negative 6. And that's going to simplify down to negative 1/3. So if the slope is negative 1/3 for line PQ, that means that for your line, slope of perpendicular line, the slope is going to be a positive 3, right? Opposite, meaning if this is negative, your slope has to be positive. Reciprocal, flip the fraction. All right, so if my slope is a positive 3, that means I'm going to go up 3, 1, 2, 3 over 1, up 3, 1, 2, 3 over 1, up 3, and so forth, or down 3 to left 1, down 3 to left 1. Okay, so did I count that right? 1, 2, 3. Yep. Okay, so here is my line for the perpendicular bisector. Okay, but the problem is asking us to come up with the equation. All right, so let's take the information we know now and come up with an equation. So your third step is to write equation for perpendicular line. Okay, in order to write an equation, if we're going to write it in slope-intercept form, you do need to know the slope, which we know the slope was 3. And you need to know either the y-intercept, which we graphed it, you know what the y-intercept is, or you can use one of the points on the line. So I'm going to use this point, the midpoint. Okay, so point that I'm going to use was the midpoint, which is 1, 2. Again, if you have the graph, I already know what my y-intercept is, but in case you aren't actually graphing, this is what you would do. So I have y equals mx plus b. I'm going to fill in the y value, which is 2, the m value, which is 3. Oh, why did I write plus 3 instead of plus b? Sorry about that. Plus b. The m value, which is 3, the x value, which is 1, and then plus b. So I have 2 equals 3 plus b, subtract 3 from both sides, and I'm left with negative 1 equals b. Okay, so now that you know, and again, I could have seen that, right? I can see the y-intercept is negative, but now that you know that the y-intercept is negative 1, so that I know b is equal to negative 1, this is the information I need to write the equation of the line. So y equals 3x minus 1 is the equation for that line. Okay, and that's what the question was asking us to come up with. Find the equation of the perpendicular bisector. All right, guys, that is it for this first lesson of chapter 6. Let me just clear this and stop presenting. All right, so I will meet you back here for the next lesson. Bye.